Welcome to the McGill Minute. My name is Mary Frances Kiffmeyer, and I serve as the marketing manager at McGill. McGill began primarily as a firm focused on water and wastewater engineering and expanded to provide services in electrical engineering, mechanical engineering, civil site, environmental, surveying, land planning and recreation, and consulting. We're glad you're listening in today as we discuss the facets of electrical engineering McGill brings to the water and wastewater industry. I'm joined today by Nick Huffman, McGill's electrical practice area lead. Nick has been with McGill for over 14 years. He and his team play a critical role in McGill's water and wastewater treatment projects by upgrading electrical systems within treatment plants, providing auxiliary power through backup generators, and providing safety and operational guidance for operators. Our electrical team's efforts ensure that operations run smoothly and can withstand unforeseen hazards. Welcome, Nick. Thanks for joining us today.
Thanks, Mary Frances, for having me today to discuss the McGill electrical team and our role we play in supporting the water wastewater staff here at McGill.
All right, let's get started. So when we talk about upgrading water and wastewater infrastructure, people immediately think of pumps, pipes, and motors, not electrical systems or sensors. In what ways does the electrical team support McGill's water and wastewater project?
Well, in our daily lives, we're surrounded by power, the need for monitoring, the need for controls to operate, everything in our daily lives, from our homes now to our cars, our phones, computers, etc. We're all connected now with those devices. And the water wastewater environment, is no different. Plants require around the clock power to provide clean drinking water to its citizens and also be able to treat that water after the citizens have used the drinking water to produce wastewater. Without water wastewater, it's very hard to have any kind of industrialized process or city. And monitoring these plants with controls is also a fundamental requirement of the plants. As with any process, it must be monitored and controlled to ensure a quality product at the end. Here we're producing water. Whether it's clean water to drink or treating wastewater to return back to our local streams or a lake, the process affects our daily lives. So as an electrical team, we work closely with our water and wastewater engineers to design the electrical and instrumentation of these processes inside the plants and the overall collection system on a sewer station or the water distribution system.
So something we hear a lot about at water treatment plants is SCADA. What does that mean?
Okay, so SCADA stands for Supervisory Control and Data Acquisition, which is the overall name for monitoring and controlling of a system or a process. And this system is comprised of a number of different elements from a main or master terminal unit, which is where all the data is sent back to, from the remote RTUs, the workstation, PCs, clients, instruments that take measurements, level, pressures, limit switches that tell if valves are open or closed, and report all that data back through the RTUs and MTUs. And to put SCADA in a perspective for someone that's unfamiliar with SCADA, think of your car. Your car is equipped with various sensors, controls, and you as the driver, you have input into some of that, whether it's the dashboard or you're reading the speed, you've got the gas pedal and brake to speed the car up, slow the car down, and the steering wheel to go left or right. And these are all considered human-machine interface devices of the car. So much like a SCADA system, you've got displays, whether it be on a computer or a small operator interface on RTU. Those are the windows to which the operator can control and operate the system. So just like your car, you're able to monitor, the speed, the radio, keep track of, engine temperature, battery voltage, what your fuel mileage is, etc., all from the driver's seat. So that's what the purpose of the SCADA system is to be able to monitor the overall system, inside the plant environment and be able to operate, turn a pump on, close a valve, monitor the level out in the tank, out in the system, and just the overall system to make sure the water treatment process runs smoothly.
So, what kinds of things can be automated with a SCADA system that are usually addressed by manual laborers?
One thing that comes to mind there is, pumping systems. So pumping systems, can be started manually, but, that requires a lot of monitoring of the system, to level, and things like that. So with a SCADA system, you're able to automate that process through various logic and algorithms. And so a process that kind of gets handled remotely and kind of a hands-off approach is a sewer lift station. These stations are typically remote and can be numerous in the systems, just depending on the terrain of the system, valleys and things that you have to be able to pump wastewater up and then gravity feed down to the next one. And so these typically operate off local controls, which monitor the level in the wet well to turn the pumps on or off based on that level. You've got various input devices, float switches, or maybe bubblers, ultrasonics, or pressure transducers can also be used to monitor the water level and turn the pumps on and off. And this system can have problems, which causes the station to go offline. And there are backups in place to try to prevent this, but it can happen. And so without a SCADA system, the local RTU there at the site reporting back to a main terminal unit, someone has to be dedicated every day to go and ensure that the station is operating correctly per NCDENR. And so with a remote SCADA RTU, that requirement goes down to once a week. And so that can save man hours, freeing up resources to use elsewhere in the system and not driving around, 4 hours a day for, one person, every day. So that can add up, reduce mileage, wear and tear on vehicles, something that can easily be seen.
So, what does the SCADA system look like to engineers compared to what the operator sees at the computer terminal?
Sure. So, from an operator standpoint, our goal is, as we're designing the system, is to have a graphical interface, something that's visually appealing and functional at the same time. A more recent technique is a technique called high performance graphic or display, meaning that there's a simple graphics that only kind of come to life when there's an alarm condition or something's out of range. A temperature might be out of range, or pressure might be too low. Something that kind of just visually you can look over at the screen and see, everything's within its normal operating range, but if not, you're going to get a red flag somewhere. Instead of some of the typical overall visual graphics that show the entire plant, and you might have, a different screen that you click on here or there. The high performance graphics give you a quick system snapshot in one easy screen. That's kind of some of the things that help the operators not spend all day sitting in front of the SCADA screen or the HMI to keep their plants up and running. And so from an engineer standpoint, these systems can be very simple or they can be very complex, kind of behind the scenes, because they've got many inputs, many outputs that have to be controlled, whether, through a digital signal, an open and closed signal, or an analog signal, which is a signal that constantly monitors, say, the level in a wet well using an ultrasonic device. And so all that has to be brought back to the system and brought back to that simple interface that the operators see. So, you got various communication methods that can be used, whether it's Ethernet, fiber, wireless, such as Wi-Fi, Bluetooth, radio system, or cellular. So there's a variety of communication methods that we look at to design a system. And a lot of that goes into the decisions that we have to make and work with a systems integrator and the client to make sure they're all happy at the end of the day.
So, what kinds of issues do you see when updating older SCADA equipment to new equipment? Are there difficulties in connecting older technologies to modern technologies?
Absolutely. And this issue, one that, over the lifespan of a plant, we've been in plants, or I've personally been in plants that were built in the late 40s, early 50s. And those plants have seen tremendous, add-ons, upgrades, throughout the years. And so one system in particular that we go in and see that, kind of started in the early 80s is some of the SCADA systems and the PLCs associated with those. And the PLCs stands for programmable logic controllers. And just like any other computer system, as one is designed, they're always working on the next design. So, more functionality, more computer power, replace the older ones. And so for the most part, most companies have a legacy type program and they kind of phase these out, but only in the last certain period of time as they fade those out, they only support the newer versions. And so you're left with older systems that are harder to connect to. And so in the water wastewater industry, we've seen this happen more and more regularly, and the equipment is no longer supported, and towns are forced to either seek used parts on eBay or other channels to find replacement parts. And in those venues, you're going to pay a premium price for something that's very, very old to keep their existing SCADA system up and running. To avoid this, we recommend, doing a system-wide study and asset inventory basically of all those devices to see where you may be able to go through an upgrade and replace, PLCs, motherboards, things like that in your system, and come up with, capital improvements cost. And so you can plan for these replacements and get them on a 5-year plan, 10-year plan, whatever the case may be, depending on the age and legacy of your system. And so, because with anything, it has a lifespan, it has a system lifespan. And typically, for electrical controls type of thing, operators that we've run across, most of them, if the SCADA or the electrical is not causing an issue, it's kind of out of sight, out of mind. It hums along, does its thing until it doesn't. And so over time, it catches up with the users and the operators of the system.
Are current SCADA systems secure from cyber attacks, such as ransomware attacks or manipulation of the system to poison a water supply or shut down operations?
So yes, they are vulnerable. Like anything, all SCADA systems can be vulnerable to a system attack. Since these are programs that are created by humans, used by humans, and maintained by humans, the system inherently has points of a possible attack. There are many ways to try to mitigate those common attacks, but given enough time, given enough resources, a crack can be found in the system. This could be taking, your whole system offline. It could up a chemical dose in the plant, which could be harmful to the water supply, or they could completely shut down a critical pumping system in the process and have an overflow, for instance, at like a influent pump station at a plant. SCADA systems didn't always prioritize secure connections, but as more attacks happen, things like that, we're trying to get on a standard practice of running these users and getting them used to updating and monitoring their system.
So how can municipalities better protect their systems from cyber attacks?
There's a few things, just kind of, I've got 5 that kind of come to mind here of, having a service contract with a systems integrator to monitor and update patches for the system. That's important because, as like I say before there, with humans design this, there's always a vulnerability they find, or, something gets updated that changes, something down the line when that happens. So it's kind of a cascading effect. One little change can affect multiple things throughout the entire system. And so making sure that's up to date and having a contract with a systems integrator who comes in and make sure everything's, up to snuff, whether it be remotely or they physically come by the plant and take a look at it. The other item here is plan for updates and patches for the computer operating system itself. One thing that we commonly see is, the operating system may be on, Windows 7 or something like that. And, we're clearly on Windows 10 and Microsoft starts like I was talking about with PLCs, they fade out that support to that system. And so they no longer issue security patches for it. So making sure your operating system's up to date is one. Dedicating a machine solely to SCADA. Don't use that machine or the computer for other tasks such as surfing or browsing the internet or checking email. Another one is perform a vulnerability study and identify, where it's got known threats or unknown threats that could happen, and a contingency plan if, things should go wrong. And then if you've got IT staff, some of our bigger cities do have pretty good IT staff, and work with them and their systems integrator to make sure that they've secured the platform as much as possible.
What kind of operational improvements can a utility achieve through modernized SCADA systems?
They're going to see improved operations, improved staff operations, and improved plant maintenance. They're able to keep up with the equipment and assets. Most of the SCADA systems have ways to monitor how long pumps have been running, and then also cross-reference that to an operational and maintenance manual to say, hey, this thing has ran, this pump, this device has been operational for 100 hours. It's time to check the bearings, check this, grease the fittings, whatever the case may be. It can alert the staff and let them know that that's happened or getting ready to happen. So being able to keep up with the equipment, make sure it's maintained properly, from that standpoint. And then the warnings and things like that, you might be able to see trends. So part of the SCADA system, you've got a historian in there. And so you can watch and monitor certain things. You can monitor levels in tanks. You can monitor run hours on pumps. Am I having to run my pumps longer to get a certain height? Does that mean in the tank? Does that mean my impeller or my pumps getting bad or wearing out? Things like that you can kind of catch through a modernized SCADA system.
What about cost? Can improved SCADA systems reduce the cost for water and wastewater utilities and consumers?
Sure. So one trend kind of in the industry and a lot of industries, but particularly water, wastewater, and even electrical and trades, I guess you want to say trades in general, is the aging workforce. We've got a big issue with the aging workforce. Probably within the next 10 years, you're going to see a huge number of people retiring and a lot less qualified individuals there to take up that. So having a SCADA system that runs well and can help free up their workforce and man hours to help save money there by having a reduced staff if you have to. You save money via energy. You can better watch how your system functions over time. On certain days, you can create trends, on if you can relate a corresponding temperature to amount of typical water usage, you might come in, on a Sunday or prepare for the week, fill your tanks up more or do something operational when you can save money. If you've got a peak shaving time or an time of use rate, you can kind of plan for that. And it also helps, like I said before, with labor shortages and things like that, which can get passed on to the consumer as in not having to have rate increases and things like that if they can save money.
Can you give us an example of how McGill's electrical engineering services improved operations for one of our clients?
Sure. I would say one example would be the City of Lenore's George Bernhardt's water treatment plant on Lake Rhodhiss. I've worked there on this site for almost 15 years of my career here at McGill. And over the years, we've replaced the city's aged PLCs, components through various processes that we've upgraded. And one thing this allowed us to do was do an open architecture SCADA network. And what is an open architecture network? So this is a network that allows system integrators to come in and service the SCADA system. Basically, anybody that that's a system integrator can come in and work on it. So while they still have a few components that are out there, we're working with them and have tried to eliminate proprietary SCADA system components where only one vendor can come in and service that equipment. And what happens there is that leaves them with a system that's vulnerable to that vendor or system integrator, wherever the case may be there. They go out of business, nobody can work on that system. And so they're kind of stuck and then have to rip it out and replace it with something new. In our electrical designs in general, in a holistic approach, we try to eliminate single points of failure when we can and provide our client with a great SCADA system to complement their hardworking staff of each town and city, which provide clean and drinking water and proper treatment of wastewater.
Thank you, Nick, for your time today.
Absolutely. Thank you for having me.
I want to remind those listening that McGill can walk you through all aspects of your next water or wastewater project or a standalone electrical project and is here as a resource to answer your questions. Be sure to learn more about the work of our electrical team on our website at mcgillassociates.com or email us at info@mcgillassociates.com. We appreciate you listening today and look forward to bringing you additional topics in the near future.